Okay, I'm Koji Fujimoto. I work for Tensor Consulting Corporation in Japan. I attended this conference 4 years ago to talk about the same topic as of today's. But I could not at that time because I got the singles on my face. Anyway, today, I'm going to talk about the solution to the prime representation polynomial formula. The famous formula, maybe you are familiar with it, is shown here. It has 26 non-negative integer variables from A to Z and is comprised of the operations of addition, subtraction, multiplication, and exponentiation. What is interesting here is we can get a prime number when we plug in arbitrary numbers for the 26 input. More precisely, the value of this formula is a positive prime number or negative integer. Moreover, with a good choice of input, all prime numbers can be found. Therefore, we can obtain all the prime numbers if we plug in just all possible value combinations and collect only positive output. The original version of this formula was introduced in 1971 by Matijasevic. After that, several variations were discovered. And Professor Wada, he is my former teacher, disclosed this formula in 1976. Shortly before Professor Wada passed away, I asked him, what are the specific 26 input values? Those make the prime numbers. So he said, I don't know. I've never calculated them or even thought about it. But it's interesting. Thank you for letting me know the idea. But apparently, he didn't try, and several years later, he passed away. Then I thought I wanted to see how this formula generates prime numbers actually. You too, right? No? But if we plug in values without thinking, we will only get a huge amount of negative values, as you can see. The structure of this formula is called Putnam Trick, which is a mechanism where this formula output a positive number if and only if all these 14 subformulas become exactly zero. It not work. Or wait a minute. Oh yeah, here. When I read the proof in Professor Wada's paper, I thought I could find the values that make these subformulas zero. So I tried to find the value that generate prime number 2. In one step, my 26 values, those generate prime number 2, is shown here. 16 of them are small numbers in at most double figures, like b equals 0 and e equals 32, and so on. But, next page, please. Well, but the value of variable a is a 55-digit integer, and x is a 111-digit one. Furthermore, the value of u is about 55 times 55th power of 10-digit integer. because variable u is the eighth power of a. Next slide. Oh. This is smaller than Googleplex, but to write this down on paper, we need a specified square. So I had a good reason to give up to write down the number here. Anyway, now I could determine the input value for the prime number 2. So it's time to try for the prime number 3. This could be the topic for the next conference. Could be? No thanks. This is too much for me. My passion has gone from this trial. But still I adore everything about the prime numbers so much. Thank you. Concludes my speech. Thank you very much.